Hello, welcome to Geomega Virtual Learning. This is the final lesson on surface area. I'm going to talk to you about surface area of Non Prisms. Please share, subscribe, and hit the notification button. This presentation will take you through how to understand the properties of cones and pyramids, and also how to calculate the surface area of Non Prisms like cones, pyramids, spheres, and hemispheres. And of course, we're going to go through an exam style question. We have a cone. And what are the properties? A cone, this particular cone is a right cone because with a vertical height in the exact middle and a slant height. So a cone has a radius at a perpendicular height to the radius and a slant height. Now if you look carefully, you can see a cone has two faces, the circular base and a curved side. So to get the formula, we know the circular base is a circle which is pi r squared, and we know that the lateral face needs to be worked out. And if you split this lateral face open, if you use paper to form a cone and you split it open, you get a sector. Or if you like, just draw a circle, cut a sector out of it, you'll be able to fold it back into a cone. Now, this sector will have the radius of L. So the radius of this sector is different from the radius of the base. And the formula for this sector is given as pi r L. And I'm going to try to go through a little bit of proof to explain to you why we have pi r L. Now, when you split it open and you form a sector, that is the circumference of the circle. So if you like, you can cut a circle, make a sector out of it and fold it into a cone. And you see that when you open it up, this bit would definitely be the same as the circumference of the circle. So the circumference of a circle is actually 2 pi r. This radius is with respect to the base circle. So in actual fact, the actual area of a sector is given by the angle over 360 times pi times L squared. The formula is supposed to be r squared, but in this case, our radius for this sector is L. That is why it's L squared, not r squared. Now, given this as circumference, we can form another expression in terms of L. This is circumference in terms of r. We can find in terms of L, because looking at this line is a fraction of a full circle with a radius L. And that fraction is angle over 360 times the circumference of that full circle, which is 2 pi L. That means these two should be equal. So I'm going to equate the two expressions, the two formulae, and this is what I'm going to have. Now, I want to find an expression for L so that I can substitute into one of the L's here. So I'm making L the subject. That will give me 362 pi r over 2 pi theta. Crossing out the common ones, L represents 360 r over theta. So if I replace one of the L with 360 r over theta, I'm going to have a formula as this. 360 r over theta is what represents L, and it's L squared, so there's another L left. Crossing out the common ones, I'm now left with pi r L, which is our formula. So the lateral curved side of a cone is given by pi times the radius times the slant height. So now the total surface area of a cone is the area of the base plus the area of the lateral curved side, which is given by pi r squared plus pi r L. So this is how the formula comes into being. So let's look at an example and use the formula. So I have a cone with the radius base of 6, height of 8, and a slant height of 10. So all I need to do is substitute 6 in place of r, 10 in place of L. So that will give me 360 pi plus 60 pi, 96 pi total. So answer in terms of pi, 2 decimal place. Total surface area is 301.59 cm squared. Now note, sometimes the slant height will not be given, and you can see the base, radius, and the height forms a right angle triangle. So if it is not given, use Pythagoras to work it out yourself. Now, surface area of a pyramid. A pyramid has 5 faces. This particular pyramid has 5 faces because the base is a square and it has 4 identical triangles around it. So 5 faces. To work out the surface area, you work out the base area, the 4 identical triangles, and you add them all. So the base is 6 times 6. The triangle has a height of 5 and a base of 6. So one triangle is 6 times 5 over 2, 15 cm squared. 4 triangles, 15 times 4, 60 cm squared. So the total surface area is simply 36 plus 60. That gives me 96 cm squared. Simple as that. So this is one of the simplest questions you could ever get, where you already been given the height of the triangle. Sometimes you'll be given the height of the pyramid and you might need to work out the height of the triangle yourself. Pause the video and try these 2 questions yourself. When you're ready, let it play. Hope you're done. 5 cm is my radius, 13 is my slant height L. Substituting to the formula, this is what I'm going to have: pi 5 squared plus pi times 5 times 13. That works out as 25 pi plus 65 pi. All is 90 pi. You leave your answer as 90 pi if you are asked to give your answer in pi. But here is 2 decimal places, so we're going to have 282.74 cm squared. Now for the pyramid, the base is 64 meters squared because 8 times 8 is 64. One triangle, height of triangle 10, base 8, 8 times 10 divided by 2, 40. 40 times 4, 160. So 160 represent the 4 triangles, add it to the base, and you have 224 meters squared. Now, sometimes you are given the height of the pyramid, but not the height of the triangle. So that's what we're going to do. So this is one of the harder ones. So you just have to look carefully at the diagram. We already know the base is 12 times 12. That one is easy to do. So we have 144 cm squared for the base. Now for the height of the triangle, I'm going to try to use Pythagoras to work it out. So this is what I'm going to do. The red line is the height of the triangle. Now, we know this side is 12 cm. That means from this point all the way through to the center to the other end is also 12 cm. And because this is the center, it makes this line half of 12, which makes it 6. And that is the height of the pyramid, which is 8. So my right angle triangle is height of 8 and a base of 6. Let's pull it aside. So using Pythagoras to find the red line, which is the hypotenuse, I'm going to use the addition rule. So it's the square root of 6 squared plus 8 squared, and that will give me 10 cm. Now that I know the height of the triangle as 10, one triangle will be 12 times 10, because the base is 12 and the height is 10. So 12 times 10 divided by 2 is 60. 4 triangles will be 4 times 60 is 240. And total surface area will be the base area plus the area of the 4 triangles, which is 144 plus 240, and that is 384 cm squared. Surface area of sphere and hemisphere. Surface area of sphere is given as 4 pi r squared, so you need to remember that 4 pi r squared. So this is a sphere, diameter is 20 cm, so half of that is 10. That gives me a radius. Substitute 10 into the formula. I'm going to have 4 times pi times 10 squared. That gives me 400 pi. And if I want my answer in 2 decimal place, it's 1256.64 centimeters squared. Now for the surface area of a sphere, you need to be careful to really analyze the phases. Don't just do surface area of a sphere and just half it and thinking that you are done. No. If you look carefully, it has two phases, the curved side and a circular flat face. The curved side is given as 2 pi r squared because it's simply a full sphere divided by 2. So the curved side represents half of the surface area of a sphere, which is 4 pi r squared divided by 2. That gives us 2 pi r squared. The flat circle at the base is simply a circle, which is pi r squared as well. So that gives us 5 pi r squared. And adding 2 pi r squared plus pi r squared gives you 3 pi r squared. So the surface area of hemisphere is given by 3 pi r squared. Now this question, we have a radius of 5 cm. Substitute 5 into r. You're going to have 3 times pi times 5 squared. That's 75 pi. And as a decimal, we have 235.62 cm squared. So note the difference. 4 pi r squared, a full sphere. 3 pi r squared is a hemisphere when we need the base has what a circular face like this. Now let's look at an exam question. Sometimes students know concept of working out spheres, hemisphere, cylinder, but they don't try to bring the knowledge into answering the question. They just do things in disjoint. If you look at this question, for example, it shows a solid shape made of a cylinder. That's a cylinder and a hemisphere. And it's given to us that the cylinder and hemisphere have the same radius, but we don't know that. So we might need to work out the radius. And the solid shape has the height of 14, the 4, including the sphere and the hemisphere is 14 cm. The curved surface area of the hemisphere is 32 pi cm squared. We are supposed to work out the surface area of the whole solid, leaving our answer in pi. That means we are not allowed to use a calculator. Now, what we need to understand about this question is that we said curved surface area, according to the question, is 32 pi. Remember, the circular face of the cylinder is hidden. The top bit is hidden. The same as the hemisphere. Also, this circular base is also hidden. So when you're working out the surface area, we will not include the circle in the middle here because that is hidden. So we need to be careful about it. Don't just work out a cylinder surface area, work out the surface area of hemisphere and add it. You will overdo it. So let's go through it step by step. So, curved surface area, we know is 2 pi r squared. 2 pi r squared, that's the formula. But we've been given that as 32 pi. So which means these two should be equal. This is the formula. This is the exact answer. These two should be equal. So we equate the two and we solve for the radius because you need the radius in order to proceed. Making out a subject, solve for radius, you divide through by 2 pi, both sides. So you're going to have 32 pi over 2 pi. That will give you 16. To solve for r, you find square root of both sides, and square root of 16 will give you positive 4. So the radius is given as 4 cm. Now, it says over here, the cylinder and the hemisphere have the same radius. So that means the radius for the cylinder is the same as the radius for the hemisphere. So let's put that in. So I have 4 cm going up, 4 cm going across. Now that we know the radius, we can now work out the height of the cylinder, which is 14 minus 4. And that is 10 cm. Now, we've already been given the curved surface area of the hemisphere. All we need to do is to work out the curved side of the cylinder and the bottom circular base of the cylinder, and we added 2 answers to the hemisphere, curved side of the hemisphere. So we start. The circular base is a circle, is pi r squared. So we put that into the formula. Our radius is 4, so that will give us 4 squared times pi, which is 16 pi. So I now know my cylinder base is 16 pi. Curved side. Curved side, remember in lesson 2, when you split a cylinder open, it gives you a rectangle. And the height will still be the height, but the length will be the circumference. So when you split it open, this becomes the circumference, that becomes the length. And circumference is 2 times pi times r. So 2 times pi times r is the circumference. Height is 10. Putting 4 as the radius in the formula, you're going to have 2 pi times 4 times 10 is 80 pi. Remember, we are not working up the top circle because it's hidden. We don't need that. So all we need is these 3 answers. So we need 16 pi, the cylinder base, 80 pi, the curved side of the cylinder, 32 pi, the curved side of the hemisphere. We add it up, and that will give us 128 pi. So the total surface area of the solid shape is 128 pi. And that brings us to the end of our lessons on surface area. Hope you've enjoyed it. Please subscribe, share with your friends, and hit the notification button so you'll be alerted of any video that I post. Thank you very much for watching.